Okay, and we're back. So once again, I'm going to simplify each one of these. So negative 2 to the second power becomes positive 4. This a, although it does not have an exponent to it, it's a 1. If there's no exponent shown, it's a 1. Using the power rule, I multiply these two together. So I would take the a and I would multiply the 1 and the 2 together, which ultimately would give me 4a to the second. Then I'm going to use the power rule with this b and that 2 and that 2. So I'm going to multiply those powers together, the 2 and the 2. That gives me b to the fourth, and I'm just going to work my way down the line. So really this first parentheses becomes 4a to the second, b to the fourth. Then the second parentheses would become 3 to the second, which is 9. And then I would then use the power rule. A to the second, so that would mean that I multiply the 2's together, so that would give me a to the fourth. And then this b, although it does not show an exponent, it's a 1, so I would multiply the 1 and the 2 together. So when I use the power rule, I get 4a to the second, b to the fourth, multiplied by 9a to the fourth, b to the second. Well, I'm not done, because now I could multiply these two together, and by multiplying I'm using the product rule. The product rule, product stands for multiplying, so when I do the product rule, it's a two-step process. The first step is to multiply the coefficients. The second step is I use the product rule by adding exponents of like bases. Okay, so to simplify this problem, step number 1 is I'm going to take the coefficients. The coefficients are always the numbers in front of the variables, which are 4 in the first parentheses and 9 in the second parentheses. I multiply those together. That gives me 36. Then the second step is I add the exponents of the like bases. So that a and that a have the same base. So I'm going to add the exponents of the a's, 2 and 4. So that simplifies to a to the 6th power. And then I do the same with the bases of b. I add the exponents up, a 4 and a 2. And so my final simplified version of this problem would be 36, a to the 6, b to the 6. Okay, so that's how I would simplify that problem. All right, moving over to this next problem here. So I'm going to simplify this one, and you can see we do have some examples. We're not going to do them all. So in this problem here, I have x to the third, y to the fifth, no outside power. And I'm multiplying it by x to the 8th, y to the 10th, no outside power. So the only thing I have to do here to simplify, the only rule I have to use is the product rule. There are no coefficients, so I don't have to multiply any coefficients together. There's no numbers in front of the variables. So all I'm going to do is I'm going to add the exponents of the like bases. So my first base is x. I'm going to add those exponents together, which are 3 and 8. That's going to give me x to the 11th power. And then my other like bases are the y's. So I'm going to add the exponents of the y's together, which are 5 and 10. And that gives me y to the 15th. So this problem would simplify into x to the 11th, y to the 15th. Okay? Last one that we'll do together here is I'm going to take the 5a. I'm going to multiply it by the negative 3b, and I'm going to multiply that by the negative 2a to the second, b to the third. So you can see there are no outside powers in this problem once again. So to simplify it, I'm just going to use the product rule. The product rule says the first thing that we do is we find all the coefficients, which is a 5, the negative 3, and the negative 2, and you multiply those together. So 5 multiplied by negative 3 gives me negative 15, multiplied by negative 2 gives me positive 30. Okay, and then I'm going to add the exponents of the same bases. So I have bases of a and b. I'm going to work in alphabetical order, so I'm going to start with the a's. That a has an exponent of 1. Whenever there's no exponent showing, that means it has an exponent of 1. I'm going to add it to, there's no a's there, so I'm going to skip that, but that a has an exponent of 2. So I get a to the third power. Then I'm going to work with the b's. So the first part right here has no b's. The second part has a b. It has no exponent showing, so once again that's a 1, and then I'm going to add it to the exponent of 3 here, and that's going to give me b to the fourth. So multiplying these all together to simplify the expression, 30 a to the third b to the fourth. Okay, and that's how we would go about doing these problems. Okay, just because we got some time, let's go ahead and do this last one right here. Where it says find the area of the triangle. Okay, so if you forgot, the formula to find the area of any triangle is you take the base or the bottom of the triangle, then you multiply it by whatever the height is of the triangle. And remember, the height has to be a perpendicular line from a vertex or a corner down to a side of the triangle, so that makes a right angle, and then you're going to divide that answer by 2. Okay, some books would say take the base, multiply it by the height, and then multiply it by a half. Okay, all right, so nonetheless, to find the area of this triangle, I'm going to take the base. The base in this case is the bottom, which is 5m to the third, n to the fourth, and I'm going to multiply by the height. The height in this case is that perpendicular line segment right there, which is 4mn to the fifth power, and then I'm going to multiply those together, and then I'm going to divide it by 2. Okay, so as you can see, there are no outside exponents, so I don't have to use the power rule. So the rule that I'm going to apply in this problem is I'm going to use the product rule. The product rule says the first step, we take the coefficients, the 5 and the 4, and then we're going to multiply them together. So 5 times 4 is going to give me 20. And then I'm then going to take the exponents of the same bases, and I'm going to add the exponents together. So I have a base of m. I'm going to add the exponents together, which this m has an exponent of 3. That m has an exponent of 1. So adding those together, I get 20, and now I have m to the fourth. And then I'm going to use the same product rule for the n's. Add the exponents together. That n has an exponent of 4. The next n has an exponent of 5, so I get 20m to the fourth, n to the ninth, but I still have to divide my entire answer by 2. Okay, now when I'm dividing by 2, the only number that I can divide by 2 would be the 20. 20 divided by 2 is 10, so my area of this triangle would become 10m to the fourth, n to the ninth. Okay, and that would be how we do that example.